Hi, this is the third in a series of videos on vector space classification. In this video, we will be discussing k-nearest neighbor classification. K-nearest neighbor is very different from Rokio classification. Like Rokio, it is conceptually simple. However, it is often more accurate than Rokio and does not have any problems with non-spherical classes. In k-nearest neighbor, rather than assigning each document to the class of the nearest centroid, a document is assigned to the class of its k, with k being a value, nearest neighbors. This relies on the idea that a document will be in the same class as other nearby documents. If k is 1, then the document is assigned to the same class as its nearest neighbor. The decision boundaries in one nearest neighbor are actually part of a Voronoi tessellation. A Voronoi tessellation breaks up a space into Voronoi cells, where each object cell consists of all points nearer to that object than any other object. Let's look back at our planet classification example. We add a new planet there. With K1, we assign our test planet to the same class as the nearest planet. A K of 1 is not a good choice. It has a very high error rate. A document can be easily misclassified because of noise in the dataset. Often, K is set to a value greater than 1. When K is greater than 1, a document is assigned to the class that the majority of its neighbors, K being the number of neighbors, belong to. Often, K is an odd number, so that there cannot be ties. Numbers such as 3 or 5 are common, but larger values like 50, 100, etc. are also used. Let's look back at our planets. Instead of K being 1, let's use K5. Now our planet looks at its 5 nearest neighbors instead of just 1. That makes it much less sensitive to noise and other problems. K-nearest neighbor also has a probabilistic version. In that version, we determine the probability that a given document belongs to a class based on the proportion of its neighbors in that class. Let's talk for a minute about training and using the standard k-nearest neighbor algorithm. K-nearest neighbor is very simple to train. The only steps are preprocessing the documents and selecting a value for K. Preprocessing the documents includes steps like tokenization. It is possible to run k-nearest neighbor without preprocessing, but that's less efficient overall. If the documents are not preprocessed during the training stage, they have to be processed each time a new test document is added. Applying k-nearest neighbor involves selecting the nearest neighbors of a given document. Then, for every possible class, estimate the probability that the given document is in that class based on the intersection of the given document's neighbors and the selected class. The training time for KNN scales linearly with the size of the training set, but the number of classes is not relevant. This can be an advantage when dealing with many classes. K-nearest neighbor memorizes the training set to compare documents. This can make it very inefficient when the training set is very large. There are implementations of k-nearest neighbor that can overcome this problem in some cases. However, k-nearest neighbor, assuming a good value for k was chosen and the training set is of a sufficient size, is very accurate. So, I hope you enjoyed this video. Thank you for watching, and please check out the other videos in this series.